In this problem, we have a hot air balloon rising vertically at a constant rate of 2 feet per second. There's a dog sitting on the ground 30 feet from the spot directly below the balloon. So that distance is 30, the distance from here to here, and it's fixed, it's constant. At what rate is the distance z from the dog to the balloon increasing when the balloon is 40 feet above the ground? So let's go ahead and start by writing down the three essential things that we need to solve a related rates problem. The first thing is to write down what we're given. And in this case, we're given the rate at which the hot air balloon is rising. That's called dy dt. And dy dt is 2 feet per second. Okay. Also, we need to write down what it is that we're going to find. And what we're looking for is the rate at which the distance from the dog to the balloon, that's called z, is increasing. So the rate at which z is changing, or more specifically in this case increasing, we call that dz dt. So find dz dt when, at the instant that the balloon is 40 feet above the ground, when y is 40 feet. And the third thing that we need is some sort of an equation that relates the dependent variables. When I talk about the dependent variables in a related rates problem, I'm talking about the variables that depend on t, which in this case would be y and z. So we need an equation that relates y and z. And since we have a right triangle and z is the hypotenuse and y is one of the legs, let's use the Pythagorean theorem. So 30 squared plus y squared equals z squared. We can clean that up a little bit, right? Because 30 squared is 900. Okay, so we've got the three basic pieces of information that we need. We've got it written down. And now it's just a matter of taking the equation 900 plus y squared equals z squared, differentiating with respect to t. So let's do that. So d dt means take the derivative with respect to t. So differentiate both sides with respect to t. The derivative of 900, of course, is 0. It's a constant. The derivative of y squared is 2y times dy dt. Do not forget the dy dt. And the derivative of z squared with respect to t is 2z dz dt. Now I can divide both sides by 2, right? 2's are gone. So I have y times dy dt equals z times dz dt. And let me move this up. Let's go back and look. We're trying to find dz dt, so that's what we need to solve for. So I'm going to solve this equation for dz dt. Well, to do that, divide both sides by z. And And then we start plugging in values. Let me go over here. So dz dt equals y. What is y? Well, y is 40, that's given. Times dy dt, which is also given. Dy dt is a constant 2 feet per second. I'm going to leave off the units. We'll throw them back on at the end. And then we have to divide by z. Now we're not explicitly given z, but we are given enough information to find z. Let me do that over here. So remember, we're looking at, we're trying to find dz dt at the instant that y is equal to 40. So I'm going to go back and look at this right triangle. At the instant that y is 40, and I want to find z, so I'm going to use the Pythagorean theorem. 30 squared plus 40 squared is z squared. You guys might notice that this is similar to a 3, 4, 5 right triangle, and if you do that, if you notice that, then you probably also be able to figure out that z is going to be 50, but I'm not making any assumptions here. I'm going to assume that you do not recognize that, which is completely fine. 900 plus 1600 is 2500. Take the square root of both sides, you get 50, like I said. So that's the last bit of information that I need. So I have 40 times 2 over 50. So let's start with this. 40 over 50, of course, is 4/5. And just a little bit more. 4 times 2 is 8. So 8/5. You could leave it as 8/5. That's perfectly fine. You could also write that as 1.6. The units, we're talking about the rate of change of distance with respect to time and everything. There were no inconsistent units. Everything was in terms of feet. So the units would be feet per second. Let's get back to the pen. Feet per second. Or you could just, like I said, leave it as 8/5. So the question that we're asked to determine, what rate is the distance from the dog to the balloon, z, increasing when the balloon is 40 feet above the ground? What rate is that distance changing? The answer is it's changing at a rate of 1.6 feet per second.